Hello guys, I have come here to explain to you projectile motion in this video. This is going to be a one-shot video. So everything, all tidbits about projectile motion is going to be covered in this video. I'm going to explain in detail everything. I'm going to make all derivations. So please be following very patiently and very carefully and attentively, of course. So now I've written already what is a projectile. Have a glance at that. A projectile is an object which is thrown at an angle theta with the horizontal other than 90 degree. So when an object is thrown at an angle with the horizontal, for example, this is a horizontal, okay? So you're throwing an object at an angle with the horizontal which is other than right angle or 90 degree. If you throw at a right angle, it is going to be thrown vertically upwards, so that is not going to be a projectile according to the definition of projectile. If you throw the object at an angle other than 90 degree, then it is falling as in the category of projectile. Okay, so if you throw at an acute angle, for example, then the object is going to move along a path like this. Okay, so the motion of the projectile, or the motion of an object which is thrown at an angle theta other than 90 degree, will be in a vertical plane. Okay, so a trajectory is simply the path followed by a projectile. Okay, the locus or the path followed by a projectile is called a trajectory. All right, so and a projectile is simply an object which moves in a vertical plane at an angle with the horizontal which is other than a right angle. All right, I hope the concepts of both these terms are very clear to you for the time being. Okay, so now examples of projectile. The examples of projectile you may just see in your daily life. Okay, if you throw a brick, a piece of stone or a brick in this way, okay, in a vertical plane, you are throwing at an angle with the horizontal other than 90 degree. You are throwing, the object is going to move along a path like this, isn't it? Object is going to move along a path like this. I've drawn the figure which you require for derivation of all kinds of this topic. Another example of a projectile, I can tell you, when a bullet is fired from a gun which the muzzle of which is pointing upwards. Many other examples you will get to find in your daily life. Okay, so now have a look at the figure. We need to understand the figure minutely in order to derive all the things which are here. When this object is thrown from this point O at the initial velocity, which is u, then this u can be resolved into two components, rectangular components. First one along the x-axis, u cos theta, the another one is along the vertical axis, u sin theta. All right, so now the object is moving along a path like this. Now what is happening to these components, u cos theta and u sin theta, we need to understand very well. So now see, the only acceleration which is acting on this body is g, small g, acceleration because of gravity, that is vertically downwards. All right, so along this vertical axis only an acceleration is acting, so that is minus g, because acceleration due to gravity always acts vertically downwards, isn't it? So now in upward direction, the component u sin theta is there, so minus g is going to act there, so that is, in other words, retardation because of gravity, right? Now along this horizontal direction, no acceleration is ever acting. Now keep in mind, the assumption which is being taken in this regard is that the motion of the projectile is completely free from any kinds of opposing force like resistance due to air or any material medium whichever is present there and in which the motion of the projectile is taking place. All right, this is the minor assumption which you are taking into consideration. So what is happening, the initial velocity is u, so its component along the x-axis, ux, is equal to u cos theta, and its component along the vertical of the y-axis, uy, equal to u sin theta. All right, acceleration along the horizontal ax is 0. I told you already, there is no such acceleration which is acting along the x-axis. The only acceleration acting on the projectile is acceleration due to gravity, so that is ay. The positive y direction, the motion is taking place, or the component we have taken the initial of the initial velocity, so ay is going to be minus g, because g acts vertically downwards, so in the upward direction it's going to be minus g. All right, so that's it. So now you try to understand what is taking place actually to these components. Since there is no acceleration along the x-axis, so this x component of the initial velocity is going to remain unchanged all throughout the motion. Okay, now since there is a retardation along the y-axis or positive y-axis more specifically, so this component u sine theta is supposed to decrease, isn't it? Because of retardation, the velocity decreases. All of us know this very well. So this component u sine theta is going to decrease gradually until it is 0 at the topmost point A. At the topmost point A, the projectile has ascended the maximum possible height it could reach. Okay, so that is capital H. I have denoted the maximum height attained or reached is capital H. Okay, after that, the vertical component, that is u sine theta, keeps on increasing again, but in the opposite direction. That will start increasing in the negative y-axis, along the negative y-axis. Okay, so that will actually keep on increasing in the downward direction. So right after the point A, the projectile will start moving along this path. So this component, horizontal component u cos theta, is remaining as it is all throughout the course of journey, but right after the point A, when the vertical component is 0, after that it will keep on increasing downwards, that is in opposite direction. So the projectile will move along a path like this and will ultimately hit the ground at the point B. Alright, u cos theta will keep on remaining same all throughout the journey. This vertical component u sine theta, starting from u sine theta, it will keep on decreasing until it is 0 at A, and after A it will keep on increasing in opposite direction, downward direction, and ultimately the projectile is hitting at B. Alright, that is actually the motion. So this entire projectile motion, which is taking place in a vertical plane, can be considered to be a sum total of two motions. One is a horizontal motion, okay, and another one is a vertical motion. These two motions are basically independent to each other, so we can consider each of them separately. No one is going to hamper the other. These two motions take place independently. As a result of these two independent, mutually perpendicular of motions along x and y axis, the projectile is moving. The projectile is having to move in a vertical plane. Alright, so that's why this topic, projectile motion, is coming in the chapter of motion in a plane of class 11 standard physics, ISC and CBSC and other state boards. Alright, so now let us come to the derivations one by one. First one I want to do is total time of journey. For that, we need to consider the vertical motion at the point A. Point A is the topmost point at which the projectile had ascended. You can see by having a look at the figure. So considering vertical motion at A, we are going to apply the equation of motion v equal to u plus at. What is the final velocity? Vertical motion I am considering, keep it in mind. So final velocity of the vertical component, which is 0, I told you, no vertical motion. The only velocity the projectile has at the point A is u cos theta. Only velocity the projectile has at the point A is u cos theta. The vertical component of velocity is 0. So v equal to u plus at. So the final velocity is 0 here. 0 equal to, what is the initial component? U sine theta plus at. How much is acceleration along the vertical direction? Is minus g, right, into t. Let t be the time taken by the projectile to move from A to O to A. Time taken by the projectile to move from O to A. Alright. So now what is coming? T equal to u sine theta by g. Okay. So this is the time of ascent. time of ascent t equal to u sin theta by g. So now the important point to be noted is that time of ascent is same as the time of descent. So the time taken by the projectile to move from the point of projection to the topmost point is equal to the time taken by the projectile to hit the ground from the topmost point. Okay. Now we need to find out the entire time of journey, the total time of journey. Total time of journey, and that is actually t, capital T, equal to t plus t, time of ascent plus the time of descent, 2 times t, that is 2u sin theta by g. 2u sin theta by g, isn't it? That is the first expression we got. Total time of journey, 2u sin theta by g. Alright. Is it very clear to you? I hope. Okay, very good. After that, we need to find out the range, horizontal range. What is horizontal range? I've already marked in the figure, have a look, which is capital R. Horizontal range means the maximum horizontal distance which is covered by the projectile is what we call horizontal range, which has been denoted by capital R. Capital R can be calculated by multiplying the horizontal component of velocity with the entire time of journey, isn't it? Because along the x-axis the velocity which is u cos theta, and the total time of journey is 2u sin theta by g. So u cos theta multiplied by 2u sin theta by g. Simply the distance equal to speed into time. How much is this? U square 2 sin theta cos theta. 2 sin theta cos theta, how much? In multiple angle chapter of mathematics, you might have done 2 sin theta cos theta is a formula for sine of 2 theta. So that is what R. U square sin 2 theta by g, alright? That is another formula. We have got horizontal range R equal to U square sin 2 theta by g. Okay. Now we need to find out the maximum height ascended. That we can find out by making use of another equation of motion, v squared equal to u square plus 2as. Alright. This horizontal range we have calculated considering the horizontal motion. I am writing for the sake of your understanding. Considering horizontal motion. Considering horizontal motion. After that, considering vertical motion. Vertical motion at A, we are making use of the equation v square equal to u square plus 2as. Final velocity v is 0 in vertical direction, so 0 square equal to initial velocity was u sin theta in the vertical direction, so u sin theta whole square plus 2 into A means acceleration in the upward direction was minus g. And what is S? The height ascended is h. We have already assumed h. So from here we are getting 0 equal to u square sin square theta minus 2gh. Okay. from here we're getting h equal to u square sine square theta by 2g. That is the expression for the maximum height ascended. Right, these two formulas are quite important for you to solve numericals of this topic. First one is total time of journey, 2u sine theta upon g. Second one is maximum horizontal range, r equal to u square sine 2 theta upon g. Third one is maximum height ascended by the projectile, h, capital H, equal to u square sine square theta upon 2g. All right, so take note of these formulas and derivations, everything. After that, an important thing I must not miss to mention to you is the condition for maximum horizontal range. A question comes like that, find out the condition when the horizontal range of the projectile is maximum. Or another kind of question comes like this, prove that the horizontal range of the projectile is maximum when it is thrown at an angle of 45 degree. That is something I'm going to show you right now. Please pay attention. R equal to R max. We have already got that r equal to u square sine 2 theta upon g. All right, so now it is very clear that r equal to r max when u square sine 2 theta is maximum, that is the numerator is maximum, u square sine 2 theta is maximum. Okay, r equal to r max if and only u square sine 2 theta is maximum. Now see, u is a constant, u is the initial velocity with which you are throwing the projectile at an angle other than 90 degree, right, which is theta. So now u is constant, so sine 2 theta has to be maximum because u and g are constants. Square is constant, so sine 2 theta has to be maximum. Maximum value of sine function is plus 1. Sine 2 theta has to be plus 1. That is sine 2 theta equal to plus 1. And for what value sine is plus 1? Sine of 90 degree. Sine of 90 degree. So from here only we are getting 2 theta equal to 90 degree. That is theta equal to 45 degree. Keep it in mind. So this is one important thing. R equal to R max when the angle of projection theta equal to 45 degree. That is a question which is given, and that is given often. Okay, keep it in mind. So when the projectile is shown at an angle of 45 degree, then and then only the horizontal range capital R will be maximum. Keep it in mind. When it is shown at an angle 45 degree, means if this is a horizontal, so this much is almost 45 degrees. So at such an angle you have to throw the projectile, then it will cover the maximum horizontal distance. All right, keep it in mind. Now after that, straight away I'm coming to the equation of a projectile. I need to rub the board. Now see, in order to get the equation of motion of a projectile, or the equation of the path of a projectile, or the equation of a trajectory, we need to consider that the velocity of the projectile after time t was v, and let the point at which the velocity was v be somewhere over here, point P, right? If I consider that at this point P the velocity was v, the velocity is along the tangent, right? And so this velocity v can be resolved into two components. If this is the velocity of the projectile at point P, so this v is supposed to have two components, vx and vy, right? Vx is the horizontal component of velocity and vy is the vertical component of velocity. Now we need to calculate the values of vx and vy. Vx, considering the motion along the x-axis, along x-axis. Vx be equal to u plus at, isn't it? How much was the initial component of the velocity? Ux was u cos theta, plus at. How much is acceleration along x-axis? 0 into t, right? P is equal to u plus at. So Vx is equal to u cos theta. And how much is the velocity along the y-axis after time t? Along y-axis, By equal to initial component along y-axis u sin theta plus at, acceleration along y-axis, minus g into t, right? U sin theta minus gt. Okay. Now how much is the value of the velocity v, modulus of velocity, equal to root over vx square plus vy square, isn't it? Square them up. If you take out u square as common from these two terms, all remaining inside is cos square theta plus sin square theta, which is 1. So all you are getting is u square from these two terms plus g square t square minus 2u gt sin theta. This is basically the expression for velocity, which is asked sometimes in the examination. That's why I showed it to you at first. After that, I'm going to come to the equation of the trajectory, equation of trajectory. Afterwards, I'm coming to the equation of trajectory. Alright. This is the expression for the velocity of the projectile at any instant after time t. Okay. Initial velocity at which the projectile was thrown was u. G is acceleration because of gravity. T is the time after which the velocity is v. Theta is the angle of projection. Alright. This is the expression for the velocity of projectile after time t. And the angle at which the velocity v is with the x-axis, if the angle of inclination is alpha, if we assume that this angle is alpha, the angle made by the velocity with the x component or with the horizontal direction is alpha, then how much is alpha? You can easily understand. Tangent of alpha is equal to Vy sin 90 by Bx plus By cos 90, isn't it? Because that is the formula for finding the angle of inclination of the resultant vector with any of the components. That's what you did earlier already right in this chapter. In case of finding the resultant of two vectors, okay, the direction of the resultant vector was calculated by using a formula like this: tan alpha equal to b sin theta by a plus b cos theta, when alpha is the angle made by the resultant with a. Okay, the one with which this angle alpha is made will be here separate, and the other ones will come in numerator and denominator, sin theta and cos theta. How much was Vy? Vy was u sin theta minus gt sin 90 Vx means u cos theta plus Vy cos 90. So all you are left with alpha equal to tan inverse u sin theta minus gt upon u cos theta. Alright. That is a formula for the angle of the velocity with the horizontal after time t. Now I am coming to the equation of the path of the projectile or trajectory. Alright. Now if we assume that the coordinate of the point P is xy, coordinate of the point P is xy, then how much is x? This much, isn't it? This much is x. And how much is y? Is this much? This much is y, isn't it? This much is y. So in order to find these values for x and y, we need to consider the horizontal and the vertical motions of the projectile respectively. Considering the horizontal motion of the projectile, we can make use of the formula s equal to ut plus half at square in order to get the value for x. So at point P, x equal to ut plus half at square. U means initial component of velocity along the x-axis, which was u cos theta. U cos theta into t, because v was the velocity assumed after time t, plus half at square. Acceleration along x-axis is 0. T square means u cos theta into t, right? U cos theta into t. This is the first equation. Here x is actually the horizontal amount of displacement after time t, and y is the vertical amount of displacement after time t. How much is y? Is equal to ut plus half at square. How much is u along the vertical direction? U sin theta into t plus half at square. Acceleration along vertical direction minus g to t square, right? Now we need to substitute the value of t from the first equation into this. How much is value of t from first equation? T equal to x by u cos theta, right? X by u cos theta. U sin theta into x by u cos theta minus g by 2 multiplied by x by u cos theta whole square, isn't it? Right, from 1. Okay. So how much is y actually? U got cancelled. Tan theta multiplied by x minus g by g divided by 2u square cos square theta times x square. That is actually the equation of the path of a projectile, or the equation of the trajectory. And the point to be noted is that this equation is completely analogous to the equation of a parabola, because the equation of a parabola is also of this form: y equal to ax minus bx square. Alright, equation of a parabola, since you can clearly see y equal to ax. A means this one tan theta, which is a constant. B means g upon 2u square cos square theta, which is also another constant. This equation is completely analogous to this equation, so the path of a projectile or a trajectory is parabolic in nature. Okay. Path of a projectile is parabolic. It's parabolic in nature. Okay, this is basically the equation of trajectory. Equation of trajectory. Equation of trajectory. Okay. So that's all for this session. This is a single one-shot video for this topic, projectile motion. That is what my intention was, to cover up all the things, all derivations of projectile motion in one single video. If still there are any confusion, feel free to let me know in the comment sections. Keep studying, stay healthy, take care, and goodbye.